I'm going to be talking about vSphere clustering today, and we're going to do a deep dive. My name is Duncan Epping. I'm a chief technologist working for the Storage and Availability Business Unit, primarily responsible for virtual volumes and vSAN, and I also enjoy talking about HA. I'll be talking with my friend Frank Denneman. Frank is going to take care of the DRS part, so he's going to come up on stage later. This is the agenda. I'm going to start with the HA basics and a deeper dive on HA itself. I'm going to run through a whole bunch of failure scenarios. When we did this session in the past, a lot of people gave feedback and they said, well, it's not deep enough, or some of them said it was too deep. But we're focusing on the people that said it's not deep enough. So what I'm going to do is I'm going to run through the failure scenarios, but I'm not going to show you the UI. I'm going to show you the actual log files of all of the different situations. So if that you end up in that particular situation, you can search for particular keywords to figure out what has happened. So that's what I'm going to focus on. Then Frank is going to pick up and he's going to start with the DRS basics, and then he'll start diving into the algorithm and explain you how things work in depth. But before we do, does anyone still remember what an HA event looked like before we had vSphere HA and vSphere DRS? Does anyone know? I can tell you what it looked like. This is what it looked like. Because if anything happened back in the days before we had vSphere, before we had HA and DRS, and I was an administrator just like most of you guys, what happened is in most cases you had to take out the server, you had to bring in a new server, which usually took a couple of weeks if you were lucky, or a couple of days if you were very fortunate, you had a really good support contract. In my case, it usually was a couple of weeks. Then you had to go to the tape library, and it usually took you, hours, maybe days to restore all of the data, right? All of that time, your customers were sitting there waiting before the application would be up and running. Of course, we have solved that problem. We solved the problem by introducing HA and DRS. Now, 80% of our customers are using HA and DRS as it stands today. For HA, that number in particular is even higher. It's about 91 or 92%. So there's a difference between HA and DRS. And that's mainly the result of the licensing. As you know, DRS is only part of Enterprise Plus licensing, so that's why we have a lower number of people using DRS. Now, there's still a number of people not using HA. So is there anyone in the room today not using HA? There's one guy. Okay. I'd like to talk to him after the session, but I can tell you, it's usually the same kind of people, and there's nothing wrong with it, because you probably have a good use case for it. In most cases, people that don't use HA or DRS, they for instance use something like instant cloning technology for VDI solutions, where a new virtual machine can be spun out instantly as soon as it's requested, so there's no point in restarting the virtual machine. Or you have container workloads, right, that have their own scheduling mechanism that can distribute virtual machines based on load, but also based on failures. So there's no need to actually restart that virtual machine. So you may have a good use case for it. Hopefully that is the case, by the way. If that's not the case, we truly need to have a conversation after the session. But let's have a discussion first about the basics. So I'm going to go over the basics rather fast, and then what I'm going to do is I'm going to discuss some of those failure scenarios. And as you can see, there are many different types of failure scenarios that HA can take care of. Most of them you probably are aware of. The compute one, we've all seen it happening, right? At some point in time, a host is going to fail, and then HA kicks in and restarts the VMs automatically. It's like magic. Within 15 to 30 seconds, the VMs have been restarted. In probably half of the cases, the application owners don't even notice. Now, there are some other scenarios where failures could occur, or other situations where failures could occur. For instance, storage connectivity could drop between the host and the storage system, which is what we refer to as an APD. VMware HA can respond to that as well. We also have these things called PDLs, which is where the storage device actually tells the host that it can't access the storage anymore. HA can respond to that. On top of that, we can also respond to operating system failures and application failures, which is not something that a lot of people use, but we have the ability if you would like to use it. Now, we do that in a couple of ways, because that question always comes, okay, how does HA knows that something has failed? Well, first of all, we use the network to communicate. So if you have 3 hosts in the cluster, as you can see in this diagram, there are 2 slave nodes, and one of those nodes is a master node. And these slave nodes occasionally will inform the master nodes that they are still alive through the network. Now, if anything happens to the network, there's a secondary heartbeat mechanism that we have to our disposal, which is a heartbeat data store, and HA can talk to the master itself through that particular data store. So it can use the data store to inform the master what the status is of that particular host. So if the network has failed, we can still use the data store to communicate. Very useful mechanism. Now there's one thing. Are there any vSAN customers in the room? Actually, quite a bunch, a lot. If you are a vSAN customer, HA won't use the management network to communicate. If you're planning to deploy vSAN and HA together, make sure that you take that into account. So we use the vSAN network when it comes to communication. Why? Well, if something has happened to the network and vSAN is not capable of talking to the various nodes out there, then HA needs to be aware of that, and the other way around. So that way we can take action when anything happens from a storage perspective or from a compute perspective. Now if you look at the UI, this is probably one of the few UI screens I'm going to show you, and it's fairly straightforward. If you look at the UI, it's fairly straightforward, right? You have all of these advanced options, and as soon as you've enabled HA. You can do things like specify if the host failure response should be enabled or not. Usually this is set to restart virtual machines. Not too long ago, one of my customers phoned me up and said, you know what? We had a host failing, none of the virtual machines were restarted. Guess what? One of the administrators was playing around with these settings, and for whatever reason he set host failure response to disabled. If you set this to disabled, none of the virtual machines will be restarted when a host fails. So take that into account. Of course there are some other options as well. Host isolation response, things like VM monitoring. We'll go over those in one by one in a bit. There are a couple of features though that were introduced recently, and those are the ones that I want to stress today, because not a lot of people are using them yet. Has anyone heard about restart priorities? Is anyone using restart priorities, is probably asked. Okay, just a few. So since 6.5, we've changed the way that mechanism worked. Before we introduced the restart priority mechanism in 6.5, basically what it did is it looked at the point of time of scheduling a restart for a virtual machine. So if a host had failed, let's say 100 virtual machines were running on top of the host, and you used a priority for those virtual machines for the restart, high, medium, low, we would start scheduling them through the high, medium, low fashion. But the problem with that was the following. Scheduling is extremely fast. Even the power on is extremely fast. HA can restart 32 virtual machines at the same time on a single host. So if you have an 11 host cluster and one host fails, we can power on 320 virtual machines at that same point in time. So scheduling using this mechanism, this particular restart priority, is kind of pointless, because all of the virtual machines are already restarted before it gets to the next batch even. So, you know, on the first second, the high priority virtual machines would be restarted, but the same second, medium and low would also be restarted. So we changed that mechanism, and now through this mechanism, you can specify when the next restart priority batch should be restarted. So you can specify that in the UI. You can say, okay, when the resources are allocated, which is what we had before, which is the scheduling part, or you could say when the actual power on event has happened. So when you see the power on event occurring in vCenter, or you could say when the guest heartbeat has been detected. So for instance, when VMware Tools reports itself alive. So if you have applications that are dependent on other virtual machines to be up and running, you could use this mechanism. Now the confusing part is the following. We also have something in UI called restart dependency. And restart dependency basically allows you to specify what the dependency is between multiple virtual machines. So you may have an application virtual machine and a database virtual machine, and you could say the application virtual machine can only be powered on when the database virtual machine is up and running. Does that sound familiar? It sounds very similar to what restart priority does. The only difference is the following. If you use restart dependency, you're actually using a hard rule. So in the example of the application and the database, if the database is not powering on, the application VM will also be sitting there. So you can imagine that if you start creating these rules and you make them rather complex with 20 or 30 virtual machines in each group, it could happen that there's one virtual machine in that particular group which isn't too relevant, that can't be powered on, but it also means that none of the other virtual machines are being powered on that are part of that next group. So be very careful when you use this. Now, I wrote a couple of blog articles on yellow-bricks.com. I actually described the way we would like to start changing this in the future. There's 4 articles that talk about the HA futures, and this is one of those aspects. First of all, I can promise you, if you go through this, the UI sucks. I can be open and honest about it. The UI engineers know this, HA engineers know this as well. That is going to change, so that is something that we're focusing on. But if you have the time, please read my blog articles and please provide feedback on some of the changes that we are proposing for HA, because your feedback is very relevant to us. We want to make sure that we actually end up building what you guys need. Okay, let's do a bit of a deeper dive then. Admission control. Now, before I start explaining what admission control is, and I don't know why the screenshots are a bit fuzzy, but I can talk through it anyway. Is there anyone not using admission control? Anyone? Just a couple of hands. Okay. So what is admission control? For those who don't know, admission control basically guarantees you that you can power on a virtual machine. That's all it does. It provides you a guarantee that you can power on a virtual machine. It doesn't guarantee you anything else. It doesn't guarantee the amount of resources the virtual machine gets, for instance. It only looks at the reservation that is required to power on the virtual machine. So if you have no reservation set, the only thing that we will look at is the memory overhead and a very small set amount of megahertz, 32 megahertz. So you can imagine that if you have no reservation set and you run 1,000 virtual machines and you're heavily overloaded on your environment and now 2 hosts fail, even though we can power on the virtual machines, they may still be starved for resources. So that is something to take into consideration. Unless, of course, you're using a lot of reservations, which I hope you're not doing, because it's kind of a static approach. Now, when you look at admission control, there are 3 ways of doing admission control. There's 3 algorithms. Let me mention the first one, failover host. Not a lot of people are using it. Why? Well, when you specify a failover host, that host is not used for anything else than HA failovers. So even DRS doesn't take it into account. Even when you're overloading your environment, DRS is not going to move any workloads to that particular host. That's why a lot of people are not using it. There are 2 other ones, percentage-based and slots-based. Now the slots-based is the one that we traditionally, probably all of us used at some point in time. And basically what it does is it looks at the largest reservation and assumes that all of the other virtual machines are the same. So if you have one large Oracle virtual machine with a 32 gig reservation, then the slot size will be 32 gigs. And we'll divide the total amount of resources by that particular slot size and then say, okay, you have 128 gigs worth of memory in your environment, the slot size is 32, so you can now power on 4 virtual machines. That's it. Not really flexible, because in most cases, you may have set a reservation on 1 virtual machine, but the majority of other virtual machines don't have a reservation set. That's why we introduced the percentage-based admission control policy. In a percentage-based admission control policy, we actually look at these details on a per virtual machine level and deduct it from the total amount of resources available. So if one virtual machine has a 32 gig reservation and the other one has an 8, we'll take both of them into account. So my recommendation always is look at the percentage-based admission control. But having said that, it's still a very static algorithm. This is also one of the proposals, by the way. We're planning on changing this to make this more flexible. But we already have something in the UI as it stands right now. All the way at the bottom, it says performance degradation tolerated, 100%. This is something new. In 6.5, we introduced this mechanism. This mechanism was actually something that Frank and I came up with when we were flying to Palo Alto, and we were discussing, like, why don't we have this? And they introduced it a couple of years later. So that is pretty cool. But what does it do? Well, using this mechanism, you can specify the amount of performance you are willing to performance degradation you are willing to tolerate after a failure. So in this case, if you set it to 100%, it basically means we're not taking this into account. So you can have an 80% performance drop. But if you would set this to 100 or to 0%, so if you set it to 0%, what we will do is we will look at the average resources your virtual machines are consuming, and we'll deduct a single or multiple host failures depending on how you've set up admission control. And then if you start reaching the threshold where the performance of the virtual machines may be degraded, we'll inform you about it. So you know that you may be violating the SLA that you had with your business owners, your application owners, right? This is something that we want to bake into admission control as well. So that admission control is actually going to do that for you. It's actually going to tell you you can't power on any more virtual machines because you're potentially violating the SLA. But we already have that today. This is just a warning. It's not admission control, but we are getting there. So it is something that I would recommend customers to use. Maybe set it to 50%. Or, you know, whatever you're comfortable with. It's not going to stop you from powering on virtual machines. It's going to give you a warning. Okay, now that we discussed the basics, let's dive into some of the failure scenarios. I think this is the most common failure scenario. Who has never experienced a host failure? Anyone? That's what I guessed, right? Everyone has experienced that at some point in time. And you know, when it happens, it's rather painful. But this is where we get to the geeky part. If you were here for an easy session, yeah, that's not it. If you look at these log files, right, it gets rather complex extremely fast because there are so many different messages in there. There's a couple of things you need to focus on. So what I did here is I actually copied and pasted the relevant parts, because if you look at this log file normally, which is the FDM log file, it has thousands and thousands of lines in there. Every single tiny thing that happens is mentioned in the log file. Now, if a host has failed, the first thing you need to be looking for is this dead connection thing and marking slave host as unreachable. This means that the master can't talk to this particular host anymore. So what will it do next? Well, what it's going to do next, of course, it's going to be checking the heartbeat. There's no heartbeats coming in from a network perspective, so we need to check the data store. That's what I just explained. On top of that, what it's also going to do is it's going to try to ping the host. So why does it ping the host? Well, you can imagine if the HA agent on the host has failed, we need to know about that as well. If the HA agent has failed, we won't be doing any heartbeat data store heartbeating. We won't be doing any network heartbeating either, but it's going to be up and running from a networking perspective. So that's what we validate with this particular ping. If we don't get a response within 15 seconds from anything, we'll start restarting the virtual machines. Before we restart the virtual machines, we need to know which virtual machines we can restart. So we'll be reading the protection list. We'll look at the protection list, and the protection list contains all of the virtual machines that were running on that host and that were powered on or powered off. Right? All of that is listed in this particular file. And after we've done that, what we'll do next is we'll simply send the virtual machines for placement that we need to restart. So we know which virtual machines need to be restarted, and we're going to restart those. Interesting part here is all the way at the bottom it says invoke DRS algorithm. This is something that not a lot of people are aware of, but HA actually has a small part of the DRS algorithm built in, and it knows where to place the virtual machines based on the load that was experienced in the past 5 minutes or 10 minutes or so. Right? So it knows that. Okay, host failure. Fairly straightforward, right? What about a storage failure? Has anyone ever experienced an APD or a PDL? Yeah, I know, I've been there. It's painful. Especially in the past, because when it happened in the past and you didn't have VM component protections, the VMs would just be sitting there doing nothing. Right? It's just rather painful. The only thing you could do is just press the power button to get the virtual machines to be restarted. But now in the UI, we actually have a couple of options, and we can specify that we need to take action based on a particular storage failure. Whether it's the APD or the PDL, that's besides the point. There's a big difference though between those two things. A PDL, you get an instant response. A PDL is a SCSI sense code that the storage array sends to the host. So the host picks up that SCSI sense code and it knows what to do instantly. It's going to fail the virtual machines, restart the virtual machines. For an APD, that's different, because an APD, we don't know what has happened. Something has happened to the network potentially, or maybe the storage system, it just completely disappeared. So we're going to wait by default for 140 seconds, then HA is going to wait for another 180 seconds, and then we're going to restart the virtual machines. The HA timer, by the way, you can change that. So it's set to 3 minutes, you can set it to 10 seconds or whatever you would like to do. Let's look at the failure scenario. So in this case, what I did is I triggered a PDL in my environment, and we're going to see what is actually happening in the log files. We have the FDM log at the top, which is on the host where the issue has occurred. So I'm going to show you different scenarios. So if you look at the host where the failure has occurred, or if you look at the master, it's going to be a different type of message that is displayed. So first of all, the host where it has occurred. As you can see, instantly it calls out a particular data store as inaccessible, instantly. As soon as that has happened, it's going to add it as well to a list of inaccessible data stores. This is something that's very crucial. We'll get back to that in a second. Of course, if you're not too familiar with the FDM.log, you probably have seen the VM kernel log at some point in time. It's also mentioned in the VM kernel log. Right? You can all find the PDL information in there as well. But more important is the following. What is going to happen when this issue has occurred? This is the master host. Again, it's listing the data store as inaccessible. But more important, as you can see at the top, VMCP storage failure has detected. It knows that it needs to do something with this virtual machine, And the second one is VMCP termination, of terminating VM, which now means it's going to kill the virtual machine that is impacted by the PDL, and then hopefully we can restart it, and that's what it does next. Again, it goes through the whole placement algorithm, sends the virtual machines over to the hosts that are still available, and the virtual machines are going to be restarted. This literally happens within about 30 seconds, right? Pretty fast. But I was just talking about that list of data stores, inaccessible data stores. So what if you're in this scenario and you try to talk to the storage guy and the storage guy doesn't want to talk to you? Any storage administrators in the room? Oh, quite a lot actually. We can take them on, it's okay. You know, this happens a lot. A storage administrator makes a change, but we all do the same thing, right? Have you changed anything? No, I didn't change anything. Data store disappeared. You don't know where to look. First thing that you can do is you can type this command, the pretty print command VM metadata. That actually shows you where virtual machines can be restarted. In this case, the compatibility matrix, that is the part that you need to be looking at. The compatibility matrix shows you the virtual machines, and it shows you the host where the virtual machines can be restarted. If a data store is not available on the host, as you can see, there's 3 different ones, 25, 26 and 8. 8 can be restarted on 4 hosts, 0, 1, 2 and 3. The other 2 can only be restarted on 0, 1 and 2. That is where we call out that we can't use that host. And then you need to go to the log file and actually figure out why. The log file will specify that. Then you take the log file and you show it to the storage administrator. Then he's probably going to tell you that he did make some changes, but he didn't want to tell anyone else. And then you can fix the problem. Okay, the other scenario. APD. This one is also interesting because, as I said, something has happened to the network or potentially the storage system and we don't know what has happened. So what is going to happen? Well, let's look at the impacted host first. An APD has occurred and pretty soon you can see that it says inaccessible, reason, all parts down. That's a pretty good hint around what has happened. So first thing you need to do is either talk to the networking guy or you need to talk to the storage guy, depending on the type of storage system that you have. If you're lucky, you're using vSAN and you can talk to your colleague or maybe even to yourself, which makes it a lot easier. After that has happened, of course, we'll start providing notifications that something needs to happen to this virtual machine. In this case, we're trying to inform the master that this virtual machine may need to be restarted. So let's take a look at that part. Here again, this is the VM kernel log on the impacted host. Let's skip this one. This one is more important. Here again we'll see the compatibility list, because on the compatibility list we are still tracking which data stores are accessible and which data stores are not accessible, as I just mentioned, right? That is important because when we restart the virtual machines, it could be that multiple hosts are impacted. If multiple hosts are impacted, we don't want to try to restart a virtual machine on the host that can't even access the storage. Back in the days of vSphere 4.0 and version before that, that is actually what we try to do. We would just keep on trying to restart the same virtual machine over and over and over on hosts that didn't have access to storage or even networking. Today we actually know what the environment looks like, and we'll wait until we find a host that can restart the virtual machine. Then we'll terminate the virtual machine if we know we can restart it, and then we're going to try to restart it. So we'll send it for placement, the VM is going to be powered on, and then you should see the state change as well. So this happens for every single, in every single case, right? So you can see the state change of the virtual machine from orange or red to green. Okay, then one of the last things I'm going to discuss is the isolation response and the partition response. Now this is always a difficult debate. There's a lot of customers who don't have the isolation response enabled, and there's a lot of customers that have the isolation response enabled. It usually depends on the stability of the network. So it's easy to always blame the network people, but it is usually them. We can be honest about it. In this case, isolation response is purely about the network. So what does it do? If something has happened to your network connection between a host, one host, and the rest of the cluster, HA can take action on that. If you've specified the isolation response, if you specified in the isolation response to power off or shut down the virtual machines, if the network disappears, that is exactly what's going to happen. We'll power off and restart the virtual machines. For vSAN, for those who are using vSAN, you should always have this enabled. Now, there's always a long debate between what an isolation and a response and a partition is. I always have this discussion with customers. They tell me, yeah, we had an isolation and nothing happened. Virtual machines were not restarted. And I ask them, did you have an isolation or did you have a partition? It's like, yeah, we had an isolation. Okay. Was it one or multiple hosts? No, there were multiple hosts. Okay. Did those multiple hosts actually belong to the same network at that point in time? Yeah, they were connected to that same switch that was isolated from the rest. That's not an isolation, that is a partition. Because in that particular case, the hosts that are connected to that same switch now will form their own cluster. They even will get their own master node. And HA will say, okay, I've got a healthy network here, I've got a healthy network on the other side, I'm not going to restart the virtual machine. There is no point. They're healthy on both sides, right? When it's an isolation, we'll kill the virtual machines and restart them. So that's the big difference between those two. And that is something that I call out in this slide. We declare the host isolated, we fail over the virtual machines. When it's a partition, there is no way we can declare it isolated because they can still communicate to each other. So we're not going to fail the virtual machines either. So that is something to keep in mind. So what does it look like? Well, it is fairly straightforward. And this one, I've seen it so many different times. It's not funny anymore. Especially back in the days when, you know, networks weren't that stable and HA didn't react too well in the 3.0 days. This is what I would always go through. So first of all, when an isolation occurs in your environment, we're going to try to ping the isolation address. By default, this is the management default gateway. If you don't have a reliable address as a default gateway, or you would like to use another address, you can specify that in the advanced settings. So you can pick any other address. The vSAN customers should be using an IP address on the vSAN network, not the default gateway of the management interface. Now, the host itself is going to ping that isolation address and is going to notice that it's not getting any response. So it's going to say, I am isolated. After it knows it has been isolated, it can start taking action. It's going to power off all of the virtual machines that it's running. But the interesting part is the following. It's going to write to the data store that it's powering off the virtual machines. So that the master actually knows that something, in this case HA, has powered off that virtual machines. If you as an administrator at the same time are powering off virtual machines, those virtual machines that you are powering off are not going to be restarted. Because HA is aware of that. It looks at this power off file. On the master side, we'll do something similar, right? We're waiting for this particular heartbeat to come in. Then we're going to check the data store heartbeat and we're going to try to ping it. Just like we did when the host was failed. The only difference is the following. As soon as we're checking the heartbeat, we'll know that the heartbeat came in and we'll specify that the host is still alive. Now that we know that the host is alive, we need to look at the disk to figure out what we need to do next. If you look at the disk, then we'll notice that there's a whole bunch of virtual machines that need to be powered on. Because we had that power off file written on that data store. Right? We read the power off files, we can now start taking action, place the virtual machines, and restart the virtual machines. Fairly straightforward. Okay. And then last but not least, what beats recovering from a failure? Avoiding a failure whenever you can. This is a feature that not a lot of people are using, but we actually have the ability to specify within the HA interface that if anything has happened to your host, whether it's a NIC failure or a fan failure or whatever it is, to start taking action based on that. It's called proactive HA. Now you need to use an agent that is provided by the OEM, so a Dell agent, HP agent, IBM agent, or whatever it is. If you've installed that and configured that, you can specify what the action should be on a specific hardware failure. So if the host, or if a fan has failed or multiple fan has failed, you can now specify that that host needs to be placed into maintenance mode. Right? It's going to move all of the VMs off, and you could potentially take it out of the cluster or start doing maintenance on it. The other option that you have is you can have it go into quarantine mode. So what does that mean? As soon as you place a host into quarantine mode, DRS is not going to place any new workloads on top of it. Even when it needs to distribute virtual machines as a result of load. So it's going to avoid using that particular host. Hopefully you can go in and then start looking at what the problem is, maybe move your virtual machines off, place it into maintenance mode yourself, and then fix the issue. Right? And with that, I'm going to hand it over to Frank, who's going to talk more about DRS now that we're on the topic anyway.
Thanks. So, funny story, Duncan called me up a few months ago. Hey, should we do a deep dive session about HA and DRS? I'm like, yeah, good idea. He said, let's go deep. I said, yeah, that's a good idea. He said, do you want to go first or I go first? I said, no, you go first. Bad idea. Because when I followed him on stage in the US, I got blank stares for 30 minutes because he fried their brains. So hopefully what I'm going to show you is a little bit, it arrives, let me put it that way. So let's start off slowly and start talking about the history, because if you understand the history about virtualization, you understand why DRS acts this way today. So when we started off with virtualization, I think this was about, for me it was 2005, so by show of hands, anybody started in 2005, 2006? Okay, cool. Some legends here. So before that, end of the 90s, there was a lot of companies that went from a mainframe to a server model. And it was like a poor Oprah episode. You get a server, you get a server, everybody get a server. Now the problem was, when they looked at the utilization, every server had approximately 4 to 5% of activity. And that's when virtualization started. Like, let's pile all those workloads together on pretty big boxes and use the hardware more efficiently. And that activity, that's the key point for DRS. That's what we decided to use in 2006 when we introduced DRS. Let's look at the activity of the workload and figure out where we can migrate the workload and balance out the activity across all the physical resources, right? But in today's world, we're thinking not only about mobility, but we're thinking about automation and availability. And now the activity is not as important anymore, especially when you think about how customers start to design their clusters, right? But when you look at the main metrics of DRS today, you can see that for CPU, we use CPUActive, some ready time, run and peak, and for memory, we take a little bit more metrics into account. But the primary one is still memory active. Now, with activity in mind, the idea is that once you build a cluster, you want to make sure that the workload can use the available resources as much as possible. So the last thing you want to do is create services that take away those resources. So what we did is we created a cost, risk, benefit analysis. So every time when DRS balances the cluster, it looks at the cost. Which virtual machine is active and what will it cost to move that virtual machine to another host. That typically means how much memory do we need to move over to another host. That takes CPU cycles, that takes into network bandwidth, but also we need to understand, is that memory active or is it idle, all that stuff. Now the risk is, what happens if we move that virtual machine to another host? It might become active again. One of the things that we do is we select workloads that are primarily idling, because the memory change is not as high, so it's easier to migrate. Now the thing with the activity is that it can spike after it's moved, because you really cannot predict the future. So what we do is we look at the last hour of activity and figure out whether the workload was kind of stable. How did the utilization look like, right? And so what we do is we try to take the most stable workloads as well, so idle and stable. Now the last thing is the benefit, and that is, what happens if I move that virtual machine from host A to host B? What's the impact on host A, the source host, and what is the impact on the destination host? Because you don't want to move a noisy neighbor. You don't want to take one that disrupts host A and moves that workload to host B, where it will disrupt new workload, right? So that's basically the algorithm that we use, or the decision matrix that we use to select the workload. So in essence, DRS balances the active workload across the cluster with the minimal cost. And now that's another thing, that we don't want to migrate workloads, right? We don't want to take away the resources for the workloads itself. So other solutions, they might want to show that they're very active, so you see a lot of emotions. Now, you have to take into account that that will take away some of your precious resources. Now, when we talk about precious resources, we can talk about CPU, but memory is typically in the mind of most people. Like I said, we're using active. But I started to wonder, is that actually still a modern thing? So I asked this on Twitter, and I'm like, what are you doing? How are you designing your cluster? Are you designing your cluster with overcommitment? Or are you saying for every virtual machine gigabyte of memory that I create, I will back it with physical memory? And it turns out that more than 60% says no. For every virtual memory, I have physical memory. Now that does not align with the DRS model, right? So we started to work at some different models inside of DRS. Now one of the things that you cannot do, you cannot change an algorithm that you've been using for 10 years. So you have to introduce additional options, and that's what we did in 6.0. And in 6.5 we added more and more, right? So in 6.5 we have 3 additional options: the VM distribution, the memory metric for load balancing, and the CPU overcommit. And let's start with memory metric for load balancing. And now let's dive into a little bit deeper into the DRS model. So here you can see the memory metrics of a virtual machine. So this is a 16 gig virtual machine. So you have 16 gigs as configured memory, but when that virtual machine is running, it's consuming memory, but part of that consumed memory is actually active. So what you see here is that of that 16 gigs, 12 gigs is consumed by the virtual machine. So that means that the virtual machine has consumed 12 gigs of physical memory, but it uses 5 gigs or a little bit more than 5 gigs. Now that doesn't mean it's the same 5 gigs over and over. That can change, right? Because the working set of a application can change, and applications within a guest OS can change, right? Now, we also use a little bit memory overhead consumption to run the virtual machine, and that means that that is the total amount of resources we use for dynamic entitlement of that virtual machine. That's something that DRS takes. So it's the 5 gigs plus the 90 megabytes. That's something DRS takes for the target for the virtual machines to load balance, right? That's the metric. But with the idea of that you're now using physical memory, or you're backing physical memory, this doesn't work. So we started to introduce idle consumed memory, so to provide you a little bit more of a buffer. So when you look at consumed memory, 12 gigs, the difference between active memory and consumed memory is 6 gigs. That's what we call idle memory consumption. It's consumed by the virtual machine, but it's not using any of it. What we said is, let's use a buffer of 25% and take that into account for our dynamic entitlement, right? So that was a little bit better. But it really didn't align with the modern way we use DRS. So when you select the advanced option, what you do is you say, no, we're going to take in the entire idle consumed memory. So what you consume, you can use, and we'll take that into account for load balancing reasons. What you will see is that you will see less migrations because it's more stable now. There's less fluctuation in the metrics that DRS sees, the change that DRS sees. So when you back your virtual memory with physical memory, this is one of the settings that you want to use, or at least what I recommend. Now, you can actually use that, or basically in the UI we have a new feature, and it's on the right side of the screen. You can toggle between active and consumed. So now you can see whether or not it makes sense to start using that advanced option a little bit more. Now, please understand this is not admission control. So DRS won't stop piling on workload if it exceeds the consumed memory, right? It basically still looks for active, and it still wants to provide placement decisions for all the workloads. So if you want to have a strict admission control, I would still recommend virtual machine memory reservations, right? But be careful with that because it impacts HA admission control. I think this is one of the most debated metrics for DRS. Everybody asks, when will DRS use ready time for load balancing? Well, it uses in some way. So I've talked about dynamic entitlement, and that's the metric that DRS uses to understand what the VM consumes within a cluster. And ready time is there. So it's a part of the equation. We don't balance on ready time. It's not what we like to call a first-class citizen. So whenever we see ready time, we start to move, but we take the ready time into account, right? So if a virtual machine has a high ready time, we still know that, hey, it still adds up to the sum. So it can increase the dynamic entitlement target, thus becoming a candidate for migration, right? If that's not enough, we have a different feature. But before I show you, you need to test this first, but not in your production environment, because it will change the migrations and it will change the activity of DRS tremendously. So what we have is we've created a advanced setting called AggressiveCPUActive. So you have to manually add that. That's not a UI option. And instead of using an average, it uses the 80th percentile. So within the 5 minutes that DRS uses as a how do you call this? A invocation window, we use 5 1-minute metrics of the usage of the virtual machine. And so in this case it uses 50, 70, 10, 5, and 5. On average, so divided by 5, that means that virtual machine has an average CPU utilization of 28%. Now if you use the 80th percentile, meaning the second highest, we now have a 50% CPU active. That means it's going to load balance more, right? Or the possibility is that it's going to load balance more. This is a very aggressive setting, so again, please test this out in an environment other than your production environment. The customers that use this are very positive about it. So if you have a high ready time in your cluster, this might be a solution for you. Now I talked about memory metric for load balancing. Another one is the VM distribution, and this is very popular in the US, what I saw from my metrics. I like to call it a peanut butter spreading your VMs. So basically spread them across all of your hosts. You can do this for if you have an IP storage based system, or maybe you have some network problems. One of the ideas is that if I spread them across my host, I have less risk when a host goes down. Now, That's not true theoretically, but it does give you a good night rest for most people. The reality is the host can still fail with the most important VMs, right? And then you're still in trouble. So what we're doing is we're not saying that, hey, we're going to spread every virtual machine equally across all the hosts. We're still making sure that it gets the resources the VM wants. So we still look at the entitlement. But we're trying to balance it, and that's the reason why we call the advanced option try balance VMs per host. First of all, we look at what's entitled to, and then can we spread these ones across the host. Now, to be honest, it's not an advanced algorithm. It doesn't look at the configuration sizes of the virtual machines. It just does a simple VM count. So that means if you have 5 hosts and you have 10 virtual machines, chances are you get 2 VMs per host, right? One host can have a higher vCPU count than the other one. But that's why we use still the dynamic entitlement for load balancing, right? The third one is CPU overcommit. And this is an interesting one from a UI perspective because it's different when you use the web client or the what's it called again? I don't even know anymore. So the thing is, it's solved in update 1. 6.7 update 1, we solved it. But if you're using an older version, chances are you have different behavior. So these are the 2 UIs, but I think this screens help you a little bit more. So when you use the HTML5 client, what we do is we use host-based vCPU to pCPU ratios. So when you set it, you have a minimum value of 4 and a maximum value of 32, allowing you to reduce the consolidation ratio per physical core, right? It's not the physical device you have in your hand, it's the per core count. Use the HTML5 client if you want to have a higher consolidation ratio. If you want to have a really low consolidation ratio, use the web client, because you can only go up to 5, a maximum of 5 vCPUs per physical CPU. Something we baked in the algorithm without actually telling you guys is the pairwise balancing. So when you move that slider, the aggressiveness of your DRS cluster, you also impact the tolerable difference, the usage difference per host. So when you use the default slider position, the moderate one, DRS takes into account that the lowest utilized host and the highest utilized host can only differ 20%. If it goes beyond the 20%, we will start to move virtual machines to reduce that difference. This is done automatically, you don't have to change anything. Now, that doesn't mean we're going to move a VM from the highest one to the lowest one. We still use or still apply the full algorithm for it. So there might be actually a more interesting or lucrative move. Now the thing is, with migration threshold level 1, we don't do it. Does anybody know why we don't do it at 1? Shout out?
There's an active powered off VM.
Exact, no, almost. So we don't load balance in 1. So what we only do is we only do mandatory migrations. So when you put a host into maintenance mode, that's when we move a virtual machine. If you violate an affinity rule, that's when we migrate a virtual machine. Putting it in 1, putting your cluster in 1, your cluster in the aggressiveness of 1 means I don't want to load balance anymore. So for some customers that have a maintenance window and they don't want to move virtual machines around, some disable DRS. Well, just slide it to 1, and you don't see any migrations anymore, other than putting a host into maintenance mode. Network-aware DRS. So this is in 6.5, or it's actually in 6, and we start to work to improve it in 6.5 and 6.7. What we do is, first of all, we call it network-aware DRS. It's not network DRS, because it's more or less a filter than a full algorithm. So what we do is we consider the network utilization of the host and the VMs when we do the load balancing. So we look at the virtual machines, and we look at the host utilization. And if the host network saturation is more than 80%, we will mark that host as incompatible or not favorable. That host won't make the list of migration destination hosts. That's basically it. We don't load balance based on network utilization alone. So if one host is more utilized than another from a network perspective, we don't migrate. That's not a first-class citizen. Now that 80%, that is really interesting, because what we do is we look at the total amount of network bandwidth. So on the left, if you have a classic design with standard vSwitches, and you assign the network or the management port groups to one vSwitch with 2 1 gig NICs, network DRS takes that bandwidth into account as well. But the VMs cannot use that. So in that design, network-aware DRS is typically not as efficient as a distributed or converged model. That's on the right side. So you have a distributed switch, you have multiple NICs, and you use network I/O control, for example, to carve up the bandwidth. In some cases, the VMs can actually use all the bandwidth. Now, in that scenario, in that design, network-aware DRS becomes more efficient, right? We are working on this to actually improve the whole algorithm for it. But I just wanted to let you know this. Now, the last thing I want to discuss is predictive DRS. Anybody in the room uses vRealize? Cool. So you can enable predictive DRS by just 2 settings. And I don't think you can see it. So the top one is the DRS cluster. That's a button that says predictive DRS. You have to enable it. You go to vRealize, you go to your cluster, and there's this other option, and I cannot even read it. I will write a blog post about it. And just enable that one, and you're clear. You're good to go. And from that point on, vRealize will provide statistics and analytics of the behavior of your virtual machines to DRS. So DRS can predictively move virtual machines around. So if we know, due to measuring the workload, if we know that a particular virtual machine spikes, we can actually move that virtual machine to a host before it spikes, where that host has enough resources. You have vRealize, just 2 clicks, and you have a more smarter DRS. And with that, I would like to thank you. We still have 5 minutes time for questions. If you do have a question, wait for the mic, because this is getting recorded. So we will, somebody will pass you the mic. You want to go on stage? Now, the last thing I want to talk to you about is today at 4 o'clock, Rubrik gives away approximately 1,000 copies of the book. So show up at the Rubrik booth at 4 o'clock and get your copy. And thank you for your attendance.
For free.